On the 21st of July, 2024, a rover on Mars pressed a hollow drill into a pale rock in an ancient river valley. The rover was Perseverance. The valley was Neretva Vallis, a dry channel that once carried water into Jezero Crater. The rock had a nickname, Cheyava Falls. It lay in a formation called Bright Angel, where layered rocks preserve a record of mud, water, chemistry, and time. Perseverance cut a cylinder from that rock and sealed it inside a titanium tube. The core was named Sapphire Canyon. It was the mission's 25th collected sample. Inside the core were small dark features that the team called leopard spots. There were also tiny dark grains called poppy seeds. The spots and grains contained iron phosphate and iron sulfide minerals associated with organic carbon. On Earth, mineral pairings like these often form when microbes use chemical reactions to live. On Mars, they do not prove life. They are a potential biosignature. That phrase is careful by design. It means a feature that might have a biological origin, but needs more evidence before anyone can say so. NASA announced the finding on the 10th of September, 2025. The announcement came with a peer-reviewed paper in Nature, led by Joel Hurowitz of Stony Brook University. The team had spent about a year putting the interpretation through outside review. The paper did not claim that life had been found on Mars. It looked for non-biological ways to make the same patterns. It reported no strong evidence for those pathways in the rock. It also did not rule them out. That is the gap. The most interesting sample in the history of the search for life on Mars is not in a laboratory. It is sealed in a tube on another planet. The instruments that could test it properly are too large, too delicate, and too power-hungry to fly on a rover. The answer may exist in a core a few centimeters wide. It is roughly 140 million miles away, depending on where Earth and Mars are in their orbits. The tube was designed to come home. The mission to bring it home no longer has support as originally planned. Mars exploration has always depended on machines that live on borrowed time. The first rover on Mars was Sojourner. It landed on the 4th of July, 1997, with the Pathfinder mission. Sojourner was designed for 7 Martian days on the surface. A Martian day is called a sol, and it is about 39 minutes longer than an Earth day. Sojourner operated for 83 sols. It was small enough to fit under a kitchen table. It weighed about 11.5 kilograms. It moved slowly across a field of rocks at Ares Vallis. It did not search for life directly. It proved that a rover could survive the landing, move on Martian soil, touch rocks, and send useful measurements home. That was enough. It changed Mars from a place only landers could occupy into a landscape a machine could cross. The lesson became a habit. Mars rovers were built with primary missions that sounded cautious. The planet then decided whether they would receive more time. Every sol after the guarantee became a gift. Every extra drive became a small act of defiance against dust, cold, distance, and wear. The machines did not know they were outliving a mandate. Their teams did. A rover is not alive. It has no fear of winter. It has no wish to continue. But a rover has heaters, batteries, wheels, seals, computers, and moving joints. Each part has a limit. On Mars, those limits are tested in slow motion. The planet does not usually kill a rover at once. It takes margin away. It covers solar panels with dust. It cracks wheels on sharp stones. It buries a wheel in soft soil. It freezes mechanisms through long nights. It waits for the one failure that cannot be repaired. The history of Mars rovers is therefore also a history of endings. Those endings matter because the evidence grew with the machines that survived them. The longer the rovers lived, the more Mars changed from a red surface into a record of ancient environments. The question changed with it. It was no longer only whether Mars had been wet. It became whether Mars had once been habitable. Then it became whether any trace of life had ever been preserved. In January 2004, 2 larger rovers landed on opposite sides of Mars. Spirit landed first in Gale Crater. Opportunity landed 3 weeks later in Meridiani Planum. Each rover had a primary mission of 90 sols. That was about 3 Earth months. Both were solar-powered. Both were expected to fade as dust accumulated on their panels and winter reduced sunlight. Instead, Mars gave them time. Dust devils and winds cleaned their panels often enough to keep them alive. Their missions expanded from short field tests into long geological traverses. Spirit found evidence that hot water had altered rocks in the past. Its route led it across plains and into the Columbia Hills. In 2009, Spirit became stuck in soft soil. The rover could not free itself. Its final contact with Earth came in March 2010. Its mission had lasted more than 6 years. Opportunity lasted far longer. It crossed crater rims, plains, and slopes. It found minerals and rock textures that recorded ancient water. It traveled more than 45 kilometers across Mars. Its 90 Sol mission became 14 years and 46 days. A global dust storm in 2018 cut sunlight from the surface. Opportunity could not recharge. After hundreds of recovery attempts, the mission was declared over in February 2019. The rover's last real message was engineering data about low power and high atmospheric dust. It was not the sentence often repeated online. The famous line about a low battery and darkness was a human paraphrase. The truth is less poetic and more precise. A machine built for 90 sols endured for more than 5,000 sols. It ended because the atmosphere itself blocked the sun. Spirit and Opportunity did not find living organisms. They did something more foundational. They made ancient Mars look chemically plausible. They showed that water had shaped rocks over long periods. They helped turn Mars from a cold desert into a former world of lakes, groundwater, minerals, and energy sources. That was the necessary ground under every later claim. A biosignature is only meaningful if the environment around it could once have supported life. The old rovers helped build that context one outcrop at a time. Curiosity landed in Gale Crater in August 2012. Its primary mission was planned for 2 Earth years. It is still operating in 2026. That makes it roughly 14 years into a mission designed to answer a focused question. Could Mars ever have supported microbial life? Curiosity was not sent to detect life directly. It was sent to test habitability. It carried a laboratory inside its body. It drilled rocks, heated powdered samples, and measured gases released from them. It climbed the lower slopes of Mount Sharp, a layered mountain inside Gale Crater. The layers recorded changing environments over billions of years. Curiosity found that Gale Crater once held water that was not instantly hostile to life as known on Earth. It found clay minerals, chemical gradients, and organic molecules in ancient rocks. Organic molecules are carbon-bearing compounds. They can be made by life. They can also be made without life. Their presence matters because they are part of the chemistry that life uses. Curiosity also detected methane in the Martian atmosphere. Some measurements showed seasonal spikes that appeared and vanished. On Earth, much methane is produced by living organisms. Methane can also come from non-biological reactions involving rocks, water, heat, or trapped ancient gas. The methane result became one of the strangest contradictions in modern Mars science. Curiosity measured methane near the surface inside Gale Crater. The European Space Agency's Trace Gas Orbiter searched from orbit with instruments designed to measure trace gases in the atmosphere. It did not confirm the methane at the levels Curiosity reported. Both observations cannot be casually dismissed. The rover measures air near the ground at one place. The orbiter measures the atmosphere from above over broad regions. The mismatch may involve timing, chemistry, atmospheric mixing, or local release. It remains unresolved. That uncertainty is important. Mars has repeatedly offered signals that are interesting but incomplete. A rover can find a clue. An orbiter can contradict it. A model can explain part of it and fail at another part. The planet is not obligated to produce simple evidence. Curiosity showed that the search for life would not be settled by one instrument or one measurement. It would require context, repetition, and samples that could be examined in ways a rover cannot manage. The next generation did not only ask what Mars had been, it also asked how humans might work there. Perseverance landed in Jezero Crater in February 2021. A small helicopter rode beneath it. The helicopter was called Ingenuity. Ingenuity was a technology demonstration. It was designed for up to 5 flights. Mars has an atmosphere less than 1% as dense as Earth's at the surface. Flying there requires large rotor blades moving very fast through thin carbon dioxide air. Ingenuity made its first powered flight on another planet in April 2021. It then kept flying. It completed 72 flights. Its mission ended in January 2024 after rotor blade damage made further flight impossible. Like the rovers before it, Ingenuity lived beyond its design life. It also changed what a surface mission could see. It scouted routes. It photographed terrain ahead of the rover. It proved that aircraft could operate in the Martian atmosphere. Perseverance also carried an experiment called MOXIE. MOXIE took carbon dioxide from the Martian atmosphere and split oxygen from it. The oxygen was breathable in principle, though the experiment produced it in small amounts. It was the first time humans made a usable resource from material on another planet. That achievement matters because Mars is mostly carbon dioxide, air, and rock. Future explorers would need oxygen for breathing and for rocket propellant. MOXIE did not build a colony. It proved a chemical pathway. Ingenuity and MOXIE were side stories to the main task of Perseverance. That main task was sample caching. Perseverance was built to collect rocks that a later mission would retrieve. It carries sterile titanium tubes. It drills cores, seals them, photographs them, catalogs them, and stores them. Some tubes remain inside the rover. Others were placed on the surface as a backup depot. Perseverance has filled 33 sample tubes. 10 backup tubes were deposited at a place called Three Forks. The rest remain carried inside the rover. The architecture assumed that Mars exploration would be a relay. One machine would collect, another would fetch, another would launch the samples from Mars, another would catch them in orbit, another would bring them to Earth. The rocks were chosen because they were not meant to be judged on Mars alone. They were meant to be questioned by entire laboratories. Jezero Crater was chosen because it preserves an ancient lake basin. A river once entered the crater and built a delta. Deltas on Earth are good places to preserve traces of life. They gather fine sediment. They bury organic matter quickly. They record water, chemistry, and changing environments in layers. Perseverance explored the crater floor first, then it climbed toward the ancient delta. Later, it entered Neretva Vallis, one of the channels that once fed water into the crater. The Bright Angel Formation exposed pale rocks that looked different from much of the surrounding terrain. Cheyava Falls was one of them. The rock contained organic carbon. It also contained the dark leopard spots and smaller poppy seed features. The reported mineral pattern placed reduced sulfur minerals near iron phosphate. On Earth, microbes can create similar patterns while drawing energy from redox reactions. Redox reactions move electrons between chemical species. Life uses them constantly. A human body uses redox chemistry when it extracts energy from food and oxygen. Microbes can use many other redox pairs. Some use sulfur, iron, or other elements in rocks and water. That is why the Cheyava Falls pattern is interesting. It resembles a kind of chemical bookkeeping that biology can leave behind. But resemblance is not proof. Mars can produce surprises without organisms. Minerals can grow during heating. Fluids can move through cracks and change a rock long after it forms. Organic carbon can arrive from meteorites. Chemical reactions can concentrate elements into spots, rims, and grains. The Nature paper considered non-biological explanations. It did not find strong evidence that they produced the observed pattern. It also said the available data cannot eliminate them. That is the honest state of the discovery. The rock is not a fossil. It is not a microbe under a microscope. It is not a detection of living Mars. It is a rock whose chemistry and texture look more suggestive than anything Mars has offered before. The strongest evidence is therefore also unfinished evidence. It is sealed, labeled, and waiting. Mars sample return was supposed to close the gap. The plan was among the most complex robotic campaigns ever attempted. NASA and the European Space Agency would use multiple spacecraft across years. A lander would reach Mars near Perseverance. A small rocket would lift the sealed tubes from the Martian surface into orbit. An orbiter would capture the sample container. A return spacecraft would bring it back to Earth. The samples would then enter high-containment laboratories for careful study. The scientific reason was simple. A rover is constrained by mass, power, bandwidth, and sterilization requirements. An Earth laboratory can use room-sized instruments. It can cut a sample into ultra-thin slices. It can measure isotopes with extreme precision. It can map organic molecules at microscopic scales. It can repeat tests with new instruments not yet invented when the rover launched. It can let independent teams test the same rock. That is how a potential biosignature becomes a stronger claim or falls apart. The difficulty was cost and schedule. A 2023 independent review estimated Mars sample return at $8 billion to $11 billion. It warned that the return of samples could slip into the 2040s under the existing approach. Those numbers changed the politics of the mission. Mars sample return had to compete with other science missions, other NASA priorities, and federal budget limits. In January 2026, an appropriations agreement stated that it did not support the existing Mars sample return program. It left $110 million for General Mars technology instead. That was not a secret decision. It was not evidence of suppression. It was a budget agreement. Its effect was still severe. The architecture designed to retrieve Perseverance's tubes no longer had the support it needed as a program. NASA can study cheaper approaches. Engineers can redesign the campaign. International partners can propose new roles. Future Congresses can restore money. None of those possibilities opens Sapphire Canyon now. The tube remains on Mars. The rover remains mortal. Perseverance is healthy enough to continue work, but every rover is a machine with limits. Its wheels, drill, electronics, and power system are aging in a cold desert. The samples inside it are safer than unsealed rocks, but they are not home. The backup depot at Three Forks gives the mission redundancy. It does not give Earth a laboratory result. The drama is not that someone is hiding the answer. The drama is that the answer may be physically preserved and practically unreachable. There is now one funded Mars sample return mission with a planned launch date. It is China's Tianwen-3. The mission is scheduled to launch in 2028. Its goal is to return samples to Earth in 2031. It does not target Jezero Crater. It does not target Cheyava Falls. It is designed around a different site and a different scientific strategy. That matters. A sample from one part of Mars cannot directly answer every question raised by a tube from another part of Mars. Mars is a planet, not a single outcrop. A returned Chinese sample could transform planetary science. It could become the first material collected from Mars and brought safely to Earth by a robotic mission. It could reveal ages, chemistry, volcanic history, surface processes, or environmental records impossible to measure in place. It would not automatically test the leopard spots in Sapphire Canyon. The strongest potential biosignature found by NASA's rover would still remain where Perseverance sealed it. That is the unresolved ending. For nearly 30 years, Mars machines have outlived their assignments. Sojourner lasted 83 sols instead of 7. Spirit and Opportunity turned 90 sols into years of field geology. Opportunity survived 14 years and 46 days. Curiosity is still working roughly 14 years after landing. Ingenuity turned 5 planned flights into 72. Perseverance did what it was built to do. It found a rock worth bringing home. It drilled the core. It sealed the tube. It gave the sample a name. The next step depends on a different kind of survival. Not the survival of motors or batteries. The survival of a plan across budgets, governments, redesigns, and time. Mars has not given us aliens. It has given us a testable possibility. That is rarer and more demanding. A claim of life needs more than excitement. It needs a chain of custody, clean laboratories, repeated measurements, and explanations that fail for the right reasons. One small cylinder may contain the best chance yet to run that test. It is sealed in titanium on a cold planet. It is waiting in the care of a rover that will not last forever. The only funded sample return path now points to a different place on Mars. The most important tube may be the one no mission is currently funded to bring home. That's Wise Source. If this was worth your time, like it, share it, and tell me in the comments what you want examined next.